Okay, here I've got a quick video on how to do um, products of exponents when you're multiplying. So I've broken it into three main ideas. Um, this one's called the product rule, this one's called the power rule, and this is just another idea that I think is a logical consequence of these two, but it's something that we need to visit on its own. But before we go anywhere with these, I want to just define some vocabulary terms so that you know what I mean when I'm referencing a few things. If I have x to the third power, also can be said x cubed, this value appears the exponent, and it's describing the number of times that we're multiplying this number, which is our base. Meaning that if I have x cubed, you'll hear me say this often in this unit, I want to write that as repeated multiplication. So what this is saying is saying that x is being multiplied by itself 3 times. So I could rewrite this expression as x times x times x. My base 3 times, okay? And so with that in mind, let's go here. And so to illustrate these ideas, or these three main ideas of the lesson, we need to look at these as repeated multiplication. I need to figure out how to simplify this expression. If I have x to the fourth times x squared, before we see the pattern, let's write these as repeated multiplication. So x to the fourth would be x times itself 4 times, and then times x squared, which would be x times itself twice. Now, as you can see, if I do this, what I've created is I have an expression that's x to the 1, 2, 3, 4, 5, 6th power. And so some of you are probably seeing the connection. You're saying, oh, it looks like I can just add these exponents in this situation. And yes, that is the rule. So if you have the same base, notice how these are both x's. So if I have x to the a power times x to the b power, that's equal to x to the a plus b power. Now look, I know the notation can be intimidating, but all that's saying is if I have a value to a power times that same value to a power, I just add the exponents, which is exactly what we did here. X to the fourth times x squared is equal to x to the sixth. Now let's move on to this idea. I now have y squared to the third power. Notice that this is not the same as this. I'm raising the power to another power. This is not the same thing as y squared times y to the third. Okay, so we need to keep that in mind. Here I'm raising the power to another power. So what I'm going to do here is, once again, I'm going to write this as repeated multiplication. If I just look at this y squared as one value, I have that value cubed. So as we learned on our other side of the paper, a value cubed just means I'm multiplying that value times itself 3 times. So let's come back to this. If I have y squared cubed, that means what I'm really dealing with is y squared times y squared times y squared. I'm going to create a little line right here so we're not getting our problems confused. But y squared times y squared times y squared. That's y squared 3 times, y squared cubed. And then once I have y squared, I can just rewrite all these as their repeated multiplication. Y squared is those, y squared is those, y squared is those. And what we see now is that we have y 1, 2, 3, 4, 5, 6 times. And so some of you are probably seeing the pattern again. You're saying, okay, so if I raise a power to another power, it looks like I could just multiply the exponents, and that is the rule. So, oh, there's our bell. Okay, and so if I raise a power to another power, I can multiply the exponents. So if I want to rewrite that algebraically over here, that's like saying x to the a raised to the b power is equal to x to the a times b power. Once again, don't be intimidated by the notation. That's just saying that when you raise a power to another power, you multiply the exponents. Now, I want to look at this third one because these are really the two basic properties, but a lot of times you'll see problems like this, and they can be confusing if we don't address them specifically. So here what I have is 7xy squared, and 7 is being multiplied by x and y because when the coefficient is touching those variables, that just means they're being multiplied. And so what I have is I have a value squared, so let's write this as repeated multiplication like we did in the other one. So that would be 7xy times 7xy. Okay? And so the next idea that we haven't really addressed in these two, but it's important here, is the idea of the commutative property. And commutative property of multiplication is just saying that when I'm multiplying numbers, I can multiply them in any order and it doesn't matter. kind of the idea, kind of over here on a little side note, that 3 times 4 is the same thing as 4 times 3. That's what the commutative property of multiplication is. So based on that idea, I'm going to rewrite this right here. I'm going to rewrite it because that's just 7 times x times y and 7 times x times y. So I'm just going to rewrite all this multiplication. And I'm going to kind of group the variables and coefficients that are the same together. So I just took that and I just reordered it because it's all multiplication. And so this would basically be the same thing as 7 squared, x squared, and y squared. And so some of y'all once again are kind of seeing the pattern. If I have a value being completely multiplied inside of parentheses and that whole value is raised to a power, it's the same as if I just put that exponent onto each of those. And if I wanted to give this an algebraic representation, it would be, I could say xy in parentheses squared is equal to, or I guess I shouldn't say squared, I'll give it the algebraic representation, to the a power is equal to x to the a, y to the a. So basically that exponent is going to apply to both of these. Now, here's our 3 main ideas for this lesson. What I want us to do now, if you're watching this video, is I've got some practice problems prepared, and I can even move those down there so that you can reference the ones above it. So I'm going to give you a second if you want to pause the video and try to work through these on your own, and then just replay the video when you're ready for me to go over them. Okay, and so what we've got is, I'll start with this example on the left. Now, I didn't line these up. These don't necessarily apply to the idea that's above them. If I look at this one, 2ab to the 5th, this is actually our third idea over here. To have a value being multiplied all to an exponent, it's the same as applying that exponent to each base. So with that same idea, this would be the same as 2 to the 5th, a to the 5th, b to the 5th. I took that exponent onto all three. And if you actually did 2 times itself 5 times, that would be 32 a to the 5th, b to the 5th. And that would be your simplified expression. So I've taken that expression and I've simplified it and created an equivalent expression right there. Let's go to this example, okay? Now this one is kind of a combination of 2 ideas. And in fact, on second thought, let's save that one for last because that one's going to be a little bit tougher. Let's go here. Once again, let's rewrite this with the commutative property. I'm kind of going with idea number 1, but there's some coefficients here. So if we apply that commutative property, that means I can rewrite this multiplication as 6 times 4 times w cubed times w squared. So I just kind of moved everything around. And 6 times 4 is obviously 24. And then w cubed times w squared. Remember, I'm multiplying 2 numbers with the same base. That's our product rule over here. And so that's going to be w to the 5th. So that would be that expression simplified. I just added those exponents to give me that 5. Okay? Now let's come back to this middle example because this one's a little bit tougher. Once again, you're probably looking at big idea 3 and saying, okay, I've got these values being multiplied inside my parentheses and that whole quantity is raised to the 6th power, so that exponent is going to apply to all 3. And so you say, oh, okay, that's easy, 2 to the 6th, but then this is weird. It's x cubed raised to the 6th power, and then we still have our y to the 6th at the end. So now what this is requiring you to do in the middle of the problem is it's requiring you to do this power of a power rule right here. So 2 raised to the 3rd power, we learned earlier that I'm going to multiply those exponents. So I have 2 to the 6th, x to the, 3 times 6 is 18, and then I still have my y to the 6th. And if I want to multiply out 2 to the 6th, I believe that would be 64, x to the 18th, y to the 6th power. Okay? So there's our 3 example problems. If you can do these 3 problems on your own, you should be good for any homework problem you have to do, and you'll probably be good for the test as well. But once again, these are our main